everyone. In the lecture today, we will go through the second part about the pavement overview. In our previous lecture, we already introduced the basic concepts in pavement design and introduced the flexible pavement. In this note, we will finish the other types of the pavement. The second type of the pavement is rigid pavement, which is generally constructed with Portland cement concrete. In rigid pavement, the load carrying capacity is achieved primarily through the slab action. With this one, it can significantly reduce the maximum normal stress reaching the subgrade. Different from the flexible pavement, which utilizes the layered system. The structure of rigid pavement is very simple. It only consists of PCC slab and granular subbase. Usually, the thickness of the PCC slab varies from 150 to 300 millimeters, and the depth of subbase layer is around 100 to 300 millimeters. Actually, the subbase layer is very important for rigid pavement. There are some failure cases in the past to verify the importance of the subbase layer. In 1960s, PCA boasted that the rigid pavement did not need a granular subbase, and they designed the Highway 401 with this assumption. Ideally, the highway is designed to work for 40 years, but only after 5 years, there will be a lot of pumping issues along the road. And this verifies the importance of the subbase layer to support the rigid pavement. By using the PCC slab, the rigid pavements can contain sufficient beam strength to bridge over the localized subgrade failure and areas of inadequate support. Also, in rigid pavement, the load is transmitted through the beam actions of the slab, and with the PCC slab, the rigid pavement can reduce the stress concentration. In that sense, the stress will be distributed uniformly to the area under the slab. In the rigid pavement, the deflection is very small, and that's also the reason we named it as rigid pavement. Also, under the rigid pavement, the high flexural strength is predominated on the surface, so that the subgrade strength is not as important as the subgrade layers in flexible pavement. In most of the cases, the rigid pavement is consisted of finite slabs with certain joints, but we also apply some continuously slabs on the road without any joint. There are many benefits of introducing rigid pavement. First of all, even though the initial construction cost is very high, in long run, rigid pavements are cheaper because we don't need a lot of maintenance cost. Second, the rigid pavement have deformation in the subgrade, but it won't be transferred to the subsequent layers so that the structure can last for a longer time. Third, the rigid pavement design is based on slab action, and they actually have very high flexural strength to support the traffic load. Also, in the rigid pavement design, there isn't any phenomenon of grain-to-grain load transfer exist, and also it has a very low repairing cost, even though the construction cost is very high. Finally, the lifespan of the rigid pavement is much longer compared with the flexible pavement. This picture demonstrates the structure of the rigid pavement, which consists of the granular subbase and PCC slabs. In most of the situations, the PCC panels are not continuous. They are connected with dowel bars. The dowel bars won't transfer any moment, but it will transfer shear force between slabs. Also, there are some surface textures added to the slabs, and they will be applied to increase the traction and sliding resistance for the rigid pavement. In general, the rigid pavement is categorized into 4 types: joint planed concrete pavement, joint reinforced, continuously reinforced, pre-stressed. The first 3 types are usually applied for highway pavement, and the last one is very commonly applied for airport pavement. The details about these 4 types of rigid pavement will be introduced in the future under the topics of the rigid pavement design. Another important factor we have to consider about the rigid pavement is the load transfer from top to bottom. The two figures here verifies the stress distribution underneath the top layers for flexible and rigid pavements. In these two figures, you can find that the stress distribution under flexible pavement is more concentrated and the value is much higher. It will actually form a deflection ball on the surface. The pressure for the flexible pavement under the top layer could be as high as 2 megapascal, while for rigid pavement based on the bending actions of the concrete slab, the pressure can be smaller than 0.2 megapascal, and the distribution is wide and uniform. In addition, if we check the top of the subgrade, the stress for the rigid pavement could be as low as 14 to 35 kilopascal, but for flexible pavement, it's around 70 to 100 kilopascal, which is much higher than the rigid pavement. In rigid pavement, we also need to think about load transfer at the joints between slabs. If the slabs are not connected or supported by subbase, then we will see that the load will not be transferred from one slab to the other, which means 0% load transfer efficiency. If there isn't any subbase layer, but the slabs are connected with down bars, then we will observe 100% load transfer efficiency. That means all the load could be transferred to the next PCC slab. In addition, if the PCC slabs are supported by subbase, we will observe aggregate interlocking effect. The load is transferred through the shear between the aggregate particles below the joint. But you have to remember that aggregate interlock exists only when cracks keeps closed. Now let's make a comparison about the flexible and rigid pavements. First of all, the flexible pavement will apply asphalt concrete as the surface, while the rigid pavement applies Portland cement concrete. Second, flexible pavements use layered system, which consists of asphalt concrete layer, base and subbase layers, while the rigid pavement usually does not have any base layer. For load transfer, the flexible pavements can transfer normal stress to shear stress through all layers, while rigid pavement should apply slab actions of PCC slab to analyze load transfer. Usually, flexible pavement has very high stress level, but the rigid pavement will have much lower stress level. In flexible pavement, you will observe rotting, fatigue cracking, top-down cracking, and so on. But for rigid pavement, if it fails, you will observe mud pumping, fatigue cracking, and so on. The third type of pavement is the interlocking concrete paving unit. The structure of this pavement consists of the soil subgrade and aggregate base, a sand bedding layer, the concrete paver wearing surface, edge restraints, and drainage structures. There will be a lot of advantages and drawbacks of this type of pavement. The most severe drawback of this pavement is that the road will be very slippery when the surface is wet, and it cracks everywhere. But the good thing is like it won't generate any new cracks along the surface. Another thing is like this pavement can be easily worked on small areas with problem. If you find any part of the pavement fails, then you can quickly replace them with the new units. This kind of pavement mainly applied for parking lot with speed limit less than 60 km per hour. And regarding to the load transmission, it performs very similar to flexible pavement. And this figure shows the structure of the interlocking concrete paving units. The edging restraint, always say that curb is very important. It provides sufficient compression for the pavement so that the pavement will sustain for considerably longer time. And this pavement also introduced a new layer, bedding sand layer. Usually the depth of this layer is around 50 millimeters. This layer It's not compacted very well before laying the concrete paver, but it will become compact very well after the units are all placed. So the materials for bedding sand should be selected carefully before the pavement is conducted. From these observations, we can summarize the elements we need to consider for the pavement design. First of all, we need to find out some possible alternatives for the design so that if the primary choice fails, we have some backup plan. Second, we need to recognize the variations of different design factors, especially about the variations of the subgrade over the time. Third, we need to choose the right materials. Especially if we want to keep the cost down, we have to use the local materials as many as possible. And then we need to consider the impact of the environment and put the design life and reliability of the pavement in the consideration. And we want to make a good pavement based on the limited budget to control the cost. Finally, from our real-world observation, we find that the trucks has major damages to the pavement. In general, one 80 kN extra load of the truck will cause as much damages as of 2,000 to 4,000 passenger cars. And that means we should design the pavement mainly for the trucks instead of the light-duty passenger cars. By summarizing all these elements, we can conclude the variables we need to consider in the pavement design, and we already introduced all these variables in our previous lecture. So in pavement design, we need to consider the materials, traffic loads, environmental impact, the performance of the pavements, and the potential distress types, and the construction cost, the rehabilitation cost, and life cycle cost. Here are listed several key factors which have very significant impact on the pavement performance. The first one is traffic volume, which is usually measured with the annual average daily traffic ADT. For traffic volume, we have to consider distributions of the vehicles, especially distribution of trucks for freeway. And for airport, we have to consider distribution of the aircraft. Also, the vehicle load and load distributions along the lane is very important. The second factor is the environment, including the precipitation, moisture, temperature gradients, freeze-thaw, wet-dry cycles. And we also need to consider the material properties for each layer applied for the pavement structure. And the details about pavement structure is also important, especially the depth of each layer. And to ensure high quality of pavement performance, the maintenance should be well scheduled along the whole life of the pavement. In real-world implementation, there are a lot of methods to conduct the pavement design, but they can all be categorized into 4 types. The first one is the experience method. In this method, we will use our past experience to conduct the design. For example, if we want to design a parking lot, we can actually set a 6-inch granular subbase and then cover it with 2 to 3 inches of hot mix asphalt. And the depth selection actually comes from the past experience. The second method is the empirical method. In this method, we will do a lot of road tests about the pavement and materials, and then a statistical model will be conducted for the pavement design. The third one is the mechanistic method. In this method, we will do some calculation of the pavement stresses, strains, and deformations. And then a mechanics-based pavement performance model will be developed for the pavement design. The first one, which is also the most popular one, is a mechanistic empirical method, ME method. It will combine the advantages of the empirical and the mechanistic methods. In this method, we will do calculation of the pavement stresses, strains, and deformations. And then instead of using the mechanics-based model, we apply the empirical pavement performance model to conduct the pavement. In this class, we will utilize the ME method for the flexible and rigid pavement design. The pavement design can be applied for both highways and airports. In general, the design concepts for both of them are very similar, but the details are different. For example, highways and airports have different geometries and traffic volumes and loads, but the pavements there can have very similar types of distresses. Another thing like for airport, usually it requires higher performance to support a heavy load. This table compares the differences about the pavements in highway and airport. First, for distress. In highway, the distress usually occurs along the wheel paths, so it happens at the edges, while at airport, the distress aligned along the center line. And second, for the traffic load, on highways, usually we will observe 40 kilonewton load per dual tire system, but for airport with the Boeing 747, we will observe 180 kilonewton per tire. For the traffic volume, every day we will observe 100 to 2,000 trucks on highway, but for the airport we can know the total number of the aircraft will vary from 20,000 to 40,000 for the whole pavement life. In addition, on highway, we cannot have an accurate prediction about the traffic. It only comes from the very rough estimation. But in airport, due to the traffic control, we know the exact number of the aircraft landing and departing from the airport. Finally, the tire pressure on highway for trucks varies from 500 to 900 kilopascal, but in airports it's much higher, it could be up to 2700 kilopascal. So the requirement in highway is usually much higher for the pavement. So in the summary, the pavements are designed to fail after a certain period of time, which would be the design life of the pavement. And there are two types of failures: functional failure and structural failure. The functional failure occurs when the pavement is unable to carry out its intended function without causing discomfort to drivers or passengers, or imposing high stresses on vehicles. The structural failures occurs when the entire pavement structure collapses, or one or more pavement components are broken down, and this will make the pavement unable to sustain the load imposed on its surface. There are actually a lot of causes about the functional and structural failure, including the inadequate maintenance of the pavement, climate and environmental conditions, the poor subgrade conditions which caused by the poor drainage system, and the disintegration of the component materials, excessive load, excessive repetition of the load, and high tire pressures. The pavement design is trying to remove the impact of these causes and design the pavement to be safe, smooth, and sustainable for a very long time. Okay, so that will be all about the lecture today. Thank you very much for your attention. And next week, we will learn the soil property.